video is to give you, our investors, an inside look at our current state of Watergy development here in Louisville. Just so you all, if you haven't met me, I have a PhD in electrical engineering from Vanderbilt. I've really been all over the place working in chemical engineering, mechanical engineering, physics, you name it. I think this is my fourth startup now, and but none of them have been as exciting as working on Watergy, honestly. Here in Louisville, we have a great team. We have two core engineers, Jordan Ballard and Gerardus O'Louis. Both of them came from us from U of L actually. Jordan handles most of our design and simulation and our CNC milling, whereas Gerardus helps with our component design, our failure analysis, our basically next level projects on how we can design them. We also complemented with a team of several co-ops over the last 18 months. This is a program where students from U of L in the engineering school actually are able to come work with us for a whole semester, so they don't take any classes. If we like them, we bring them on for another co-op up to a maximum of 3, and then eventually, if everything goes well, we hire them as full-time engineers. Jordan was actually a product of that, so we're pretty proud of it. In Louisville, we have established a fully functioning machine shop equipped with CNC milling. We can mill up to about 3 feet by 3 feet by 3 feet, plasma cutting on a 8 foot by 4 foot table, large area fast 3D printing. Now these are real fast, like you can't even see the filament moving back and forth. Large area routing, so for cutting our insulation board, welding, lathing, modeling simulation, material handling, you name it, we can do it here. And I should just note that these capabilities all work together where we can almost go from concept to reality for most products in around a week or less. So it's great to be able to do that, and it's vastly expanded our fabrication abilities. So I took over, while I started Zero back in August of 22, it wasn't until March of 23 when most engineering was transferred up here to Louisville. So just to give you all an idea of how fast things have moved since then, May of 23, right after the Derby, it was the Monday after, which everybody's moving slow, we received our first core. And core is the ceramic piece in which all combustion happens. Within 3 months, so by July, we had the first Generation 1 Louisville system up and running with that core. That included designing the heat exchangers, all the piping, all the blowers, everything in only 3 months. And with that system, we were able to demonstrate 5 tons of cooling by September of 23. That system wasn't the prettiest, but it was a great proof of concept to show that all of the capabilities that you've been told about Watergy are real and they can be done, and sold me on the tech. From September to December, we were optimizing the system and trying to figure out what we needed to address, what we wanted to change for the future embodiments. And then in December, we started the concept phase of our Gen 2 system, which is currently operational right now. It took us again only about 3 months to build this other system, which was maybe about 3 times the complexity of the Gen 1, and so we're rolling. But that system, we were able to demonstrate 8 tons of cooling, and we should be able to be at 10 tons probably by tomorrow, honestly, but we're testing a new oil pump, which I'll get into in a minute. Now this month, we have begun the design of our field units. These are going to be on a 8 foot by 15 foot skid that houses all parts associated with the Watergy, including the feeder, the hopper, the conveyor, the heat absorption chillers, the piping, the ancillaries, you name it, one system ready to go. It will be able to fit into a Connex container or be transported as is. So it should be ready for beta testing very soon. I would like to take a few minutes to go over some of the great innovations that we've made over the last 18 months, because it's hard to believe it's only been that long. First is we have demonstrated the Heat2 cooling, and we have established a partnership with a wonderful company called Rober. They are based in Italy. While they do have a small North American headquarters, they want to use us as their springboard for a full expansion in North America. And these are so turnkey. We supply the heat, they make the cooling. You couldn't ask for a better system. We've also developed multiple heat exchangers in-house, mainly two different families. One is an air-to-air, where the flue gas actually heats up clean, fresh air to make very clean, high temperature hot air coming out. The second is where it's called an air-to-liquid, and we use that to heat oil with the hot flue gas. Both of these don't prevent zero cross-contamination of the flue gas to the product to be heated, and they are highly efficient. Now I can say we are shifting to the air to oil as our primary heat transfer mechanism because we're able to reduce the size by a factor of about 5. So it makes manufacturing costs lower, implementation lower, and a lot less moving parts. We have developed a grinder. After, I think, 2 embodiments now, we settled on a great grinder design that can handle almost anything you can throw at it and produce very fine particles perfect for feeding into the Watigy. I should note that all of the components were designed to be used with stamping processes, so these things can be churned out at a fraction of the cost of what would be commercially available. Heat to electricity. We have a partnership with Black Box Energy for a proprietary, highly efficient direct heat to electricity conversion technology. And we have the heat exchangers demonstrated, they have their turbine and generator demonstrated, and in this Gen 3 system that we're working on, they'll finally be married. Material feeding, we have 2 material feeding systems that we've developed. I think it's clear that, let's say, cardboard is going to be delivered differently than municipal solid waste. So we wanted to get 2 baselines there, which we have. They're working wonderfully. And for any gaps that might be filled for some exotic waste streams, there are plenty of third parties available that could help us to reduce the development time. Finally, one of our huge innovations has been our single pour mold. That one is where, rather than having multiple pieces of ceramic to comprise the combustion chamber, we have one huge pour with 3D printed parts that are melted out in the middle. This reduces time by probably a factor of 3, makes a much more leak-tight system, much more reliable process, and all around much better for manufacturing. Currently, all aspects of an HVAC only system have been demonstrated, validated, and are ready for field testing. Our current system is optimized for wood and cardboard waste, but we should be moving towards municipal solid waste very soon. Of course, fuel prep needs will be a little different. For instance, if we have a customer that supplies very wet fuel, we might want to dry that down to prevent caking or clumping. We have a partner ready to rock and roll as soon as we want to move forward on that. Further, we have a new ceramic material that should prevent any clumping or negative impacts associated with using municipal solid waste, mainly to prevent the caking that might happen in the middle. And we're ready to demonstrate 10 kilowatts of electricity in Gen 3, and we will be moving very fast from there up to the full 35 kilowatts of electricity. A cool thing about our Gen 3 system is that every component is modular and it's meant to be field replaceable. So our core, very large ceramic block. Let's say hypothetically a crack develops, and it's something that we didn't notice when we were doing our quality control. But again, things always just slide through the cracks. This will be a self-insulated structure that can actually roll out, a new one popped in the field, minimal downtime for the customer, and this also drastically reduces our long-term costs of keeping them operational. Of course, long-term, once we've done a failure analysis of long-term of each component, we then can remove some of this modularity to make a more compact system. We have a complete CAD of our system that is ready to go to a manufacturer for development. And just as a little taste, we think we're going to be demonstrating the first continuous destruction of wastewater PFAS ever. by the end of the month. So stay tuned and I'll update you all on that after it happens. To let you all know our timeline moving forward, we plan to do our first 24-hour run middle of July. Our main limitations and holdup are the availability of fuel and where we can store that, but also manpower and having it hot enough so we consistently have a thermal load on our system. We then are looking to do a first 1 month run in early September. And the reason for that gap is we want that 1 month run to be on our Gen 3 system. Of course, we can do it in Gen 2, but to save money, we're going to be scavenging some of the components from Gen 2 and putting it in Gen 3. So that September timeline, that buys us a little time there. We plan to have full automation by October. We have a wonderful partner in Belgium who's already developed our electrical panels. All the processing and computing power there is already there and ready for full automation. But and we hope to have that system implemented in by next month. And